In this episode, the engine is removed from the bike, modified and fitted to the chassis. The donor is this 2017 Honda CBR 500R. First job is to remove the engine and components. Now the engine can be placed in the frame. An engine hoist will make this easier. The first modification is to the height of the engine, which can be lowered. The sump is quite tall and this can be shortened. I'm also going to increase the capacity of the sump by extending the base. The oil pickup pipe will also need shortening to match. There should be a gap of around 10mm between the base and the bottom of the pipe. I took this to a local welder to weld up. In order to protect against oil surge under cornering and raking, I'll be adding some plates to box the oil in. I'll fit some oil flaps as well. Sump plates that bolt between the sump and engine are another possibility to guard against oil surge. Once back from the welder, the sump can be fitted using some sealant. The output shaft and water pump are next. The original chain drive sprocket is replaced by a prop shaft adapter that is available online. This one was from a Suzuki GSXR that has a similarly sized shaft. The problem here is that the water pump is in the way and needs to be modified. For this, I made a 90-degree tube bend with aluminium pipe and glued it in place. This leaves just enough room with the pipes fitted for the prop shaft. I've tried to line up the differential and output shaft as centrally as possible to reduce the prop shaft angle. I got it down to 15 degrees, which is still quite a large angle, so a sliding shaft will be required. The stub shaft is available from kit car suppliers, and I had it welded up by a prop shaft specialist. The working length is around 364mm. The engine can now be placed in the chassis for positioning. I've raised it to sit 10mm above the bottom chassis rail, and it's as far to the left as possible to centralise the output shaft. I'll start with the right hand mount. The bracket will need some short blocks fitted to the top chassis rail to mount to. For the lower right hand mount, I'm using 2 angle brackets fitted to the chassis floor. These are made from 3mm steel plate. One angle is bolted in place and the other one welded. Here we can see the 2 left-hand mounts. The rear one is a simple angle bracket bolted to the chassis rail. The front one picks up the upper part of the front crankcase. Once happy, these can be bolted up to ensure all the brackets and surfaces are mounted flat and rigid. With the engine mounted, the exhaust pipes can be fabricated. There's quite a tight bend required, and I've tried to use as much of the original exhaust as possible. The original header pipes will be cut short and attached to some 32mm tubing. As you can see, this has required multiple chops and welds. It just clears the chassis and bodywork, and the original catalytic converter can also be modified to fit. If you're fitting a modern engine, you'll likely need to retain the cat for legality. The silencer and tailpipe can be added during the bodywork stages. Next up is the airbox. The original throttle bodies are used, but the large and bulky airbox needs cutting down. I've combined the original plastic base and trumpets with an aftermarket filter. Some sealant and aluminium sheet is required to box it all in. The trumpets fit as normal. Some modification is required for a throttle cable. Finally, the oil cooler can be added. This uses a sandwich cooling plate and the smallest good quality oil cooler that I could find. This is a little bit larger than ideal, and I've fitted it between the chassis and the bodywork. I've added some brackets to mount it upright using 2 rubber bushes. Knacker ducts are used to guide the air in and out, and a base plate and ducting will be needed to mount them together. Final positioning of the ducts can be carried out during the bodywork fitting stage. In the next episode, we'll be looking at all the other parts used.